Hello, welcome back to my stream. My name is Tom. Today I'm going to do a short demo on how to set up a simple Three.js uh, game. So I've had a lot of questions on my channel about how to do this, how to create a 3D game in JavaScript. So I'm going to do a little session on how to set up the basics. I'm also streaming on Twitch. So I've got the Twitch chat open, so if anyone drops by, then they can ask me questions. But in my experience, not a lot of people do. So, but we'll see how it goes. So, Three.js is a popular sort of library for doing 3D graphics using WebGL, which is the open source or open standard for 3D graphics in the browser using JavaScript. All you really need to know is that's the library we're going to use. And what I'm going to do is take you through the tutorial code from the Three.js website and add a little bit more. This isn't really a JavaScript tutorial, so I'm not really teaching how to do JavaScript, but if you know a little bit of JavaScript already and you're interested in making a game, this should be pretty useful for you. So we're going to start by going to the Three.js website, and we're going to so this is Three.js. You can see a bunch of example projects that people have made in very impressive things you can make with it. And we're going to go to the documentation section, and on the first page, they've got a load of sample code. So if you're not familiar with Three.js, then I would recommend reading through this and getting familiar. But I am going to explain everything in here in this video, so you could just watch. But what we're going to do is just take the example code that they've kindly provided, copy it, and then in your text editor of choice, I use Sublime Text. We'll create a new file, and we'll paste in the code, and we'll save it as index.html in a new empty folder somewhere. I've just called it example project. And then we'll need a folder called, a new folder in there called JS for JavaScript. And what's happening in this HTML file is the first thing it's doing is linking to a file called Three.js. So there's a link in this web page to download Three.js, the actual Three.js library code. So we can click on it. What happened there? Maybe we'll open it in a new tab, and then we can copy code. And then we'll create a new file in the JS folder, and we'll save it as Three.js. So now, if we, in our web browser, I like to use Chrome, if we open that file, index.html, that we created, we should get a spinning green cube. So let's take a look at what the code to produce this cube looks like and what it does. So we've got an HTML file, we've got a title. Let's change that to my first game. Changes the title. We've got some CSS. This just makes sure that the canvas where all the 3D graphics are rendered by Three.js fills the page. So if you go into the developer tools in Chrome, so click on this menu in the corner, more tools, developer tools. This is really handy if you're doing any kind of JavaScript. You're going to need to use the developer tools a lot. And then we can see the elements. We can see a canvas element, and if we hover over it, we can see that it's filling the whole screen. So that's what gets created in the code I'm about to show you. And that canvas element holds all of the 3D graphics. So, as I said before, the first thing it does is it includes the Three.js code. And then in our code, we create a scene. So everything in Three.js exists in one scene. So you create a single scene and then you add all the things to it. So you can see here we're adding the cube to the scene. And then every Three.js game or app needs a camera. So the camera is the perspective of the viewer when viewing the 3D scene. So you can see the camera in this instance is looking at the cube. This might be a weird concept, but if you just think of it like a TV camera recording everything that's happening, instead of recording it though, it's sort of viewing it for the browser. I'm not explaining that very well, but it should be fairly obvious. Then we've got a renderer. This is the thing that actually draws the 3D objects. So it renders them to the screen. So this line is where that canvas element gets created and added to the document. So if we take this out, we just have an empty web page with not much in it, and you can see the canvas element isn't there anymore. So DOM element of the renderer is a canvas element, and that's what's getting appended to the document. Again, you don't really need to worry about all this stuff, just copy and paste it, and you should be good to go. Now we'll get into the meat and potatoes of how to create the cube on the screen. So every Three.js object consists of some geometry and a material. So the geometry here is a special kind of geometry called a box geometry. It basically holds all the points in the 3D object that describe how it's made up. And this box geometry just takes 3 parameters. The first one is how wide the box should be, then how tall it should be, and then how deep it should be. So 1 unit wide on the x-axis, 1 unit high on the y-axis, and then 1 unit deep on the z-axis. If we just stop it spinning for a second, we can see that if we change this to 2, then we get a rectangle instead of a square, or instead of a cube. If we change this to 2, then we get sort of a long rectangle. And then if we change this, we'll actually not see any difference because we're looking at the cube straight on, but it's actually got longer. If we move the camera up a bit, we might be able to see that. I've gone too far. Too far still. Yeah, so you can see, it's kind of hard to see because there's no shading in the scene yet, but the cube's kind of long. And if we put that back to 1, it's not quite as long. So that should explain how the geometry of the cube is created, and this material describes how to render it. At the moment we're using a simple material called a mesh basic material, and all we're doing is setting the color of the cube. So this is a hex value that describes, it's basically a big number that describes the color of the cube. And so the way it works is the first 2 digits here will describe how red the cube is, not red at all in this case. The other 2 digits will describe how green it is. If you're not familiar with hex, I suggest Googling it, hexadecimal. I'm not going to go into many details, but all it is counting from 0 to 16 instead of 0 to 10. So it's got the numbers 0 to 9 in it, and then A, B, C, D, E, and F. So this is a really big number counting in hex, and it basically means 256 in hex, FF. So this is how green the cube will be, completely green, because FF is the highest it can go. And then the last 2 digits are how blue it is, so not blue at all. So if we change this to be 0000 FF, we should get a blue cube. Yeah, and if we make it completely red as well, I think we should get like a pink or purple cube. Yeah, kind of a magenta, bright pink color. I quite like yellow, so let's try and make yellow. That's actually red and green in RGB. Okay, so we've got yellow cube. So then we create the cube from the geometry, the box geometry there, and the material, the basic material. So it gives us our cube object, and then we add it to the scene. Now every 3.js object, when you add it, unless you've, hello Matty Plays, we are looking at, I'm just doing a basic tutorial on using Three.js to make a simple game. We've basically just copied and pasted the example code from the Three.js website, and I'm talking through it. So we've just added the cube to the scene, and as I was saying, every cube, every Three.js object will have a position of 0, 0, 0, so it'll be right in the middle of the world. And then the camera itself, when it's created, will also be right in the middle of the world. So we're moving the camera down the z-axis, away from the cube, 5 units. So in the 3D world, you've got the x-axis, which moves left to right, the y-axis, which is up and down, You might have seen that from when I was moving the camera about earlier. And then the z-axis, which moves forward and backward in the world. So we moved the camera forward 5 units, and it's looking back at the cube now. So if we didn't do that, both the cube and the camera will be at 0, 0, and the camera is inside the cube. So we don't get anything on the screen because the camera is inside the cube looking out. And Three.js doesn't bother to render the inside of the cube because you're not expected to ever see it. So that's why we've moved the camera so we can actually see the cube. And if we didn't move it so much, we'd be zoomed in a bit more. So then we've got this render function. So what this does is, this is the function we're using to actually render the elements to the screen. And this is getting called 60 frames a second by this request animation frame. So what happens is we call render once, and then every time it's called, it asks Chrome to please call me again the next time we can render a frame. And that, practically speaking, that means once every 60 frames a second, as long as the computer is running fast enough. And then we rotate the cube on the x and y axes. So rotation in Three.js, you can think of it like you take a stick and you push it through the object along that axis and then rotate the stick. So in this example, if we comment out the Y rotation code and just rotate around the x-axis, what we're doing is taking a stick and then pushing it through the cube and then rotate along the x-axis and then rotating. So if I refresh the page now, the cube is just rolling over like this. And we can do the same on the y-axis. So we'll put a stick through the y-axis and then turn that stick and it will turn the cube around this way now. But obviously if you rotate around both, it sort of goes crazy, like you've just sort of thrown it in the air or something. And then we call, on the renderer we created earlier, we call render, pass in the scene we want to render and the camera that's inside the scene. And Three.js does all the hard work and actually does the 3D rendering. So what we're going to do next is listen for input on the keyboard, and we're going to use the keyboard to control the movement of the cube instead of it just constantly rotating. So we're going to create a new file, and we'll call it input.js because it's going to handle the keyboard input. We'll create a new JavaScript class. Classes in JavaScript are called functions in JavaScript are kind of JavaScript classes. As I said, this isn't going to be a JavaScript tutorial, so I'm not going to go into detail there, but we'll start by creating a sort of scoping helper here. Like, again, I don't want to go into too much detail, but if you've done a lot of JavaScript, you've probably done something similar. This just allows us to have a safer version of the this variable, which doesn't get confused because of scope and things. And then we'll add a function, handle key event, that takes the event that's happening. And for now, we'll just log to the console what that event is. So this is a really handy function call. So this will write anything you pass to it to the console in the developer tools. So if I call console.log in our render function, say rendering frame, and then open the console and refresh the page, you can see whatever we pass to console.log is getting printed out here, which is really handy. So just to make sure things are working, we'll just log the event. And the way that we handle the event, listen for the event, is we call document.add event listener. So if you want more information about that, you can Google it. But basically, this is how you listen for keys in JavaScript. And here's some handy documentation about it. So we're going to listen to the key down event, so every time a key is pressed down, and then we're going to pass it a function that should get called every time a key is pushed, and we'll delegate to our handle key event function above. and we'll have a boolean called isKeyDown. And because we're doing this on the key down listener, we'll say true. So now we need to import that input.js file from our main index.html file, and then create a new input object. And then if we refresh the page, anytime, if we just click on the canvas to make sure it's focused, anytime we push the button now, it's logging the keyboard event, which is coming from this line of code. So what we actually want to do is say, have a member variable on input. It says, is any key down? And we'll set it to false, and then in our handle key event we'll assign it. So this is just storing whether or not a key has been pressed. And then in our code we can check the input object, is any key down? And if that's true, we'll start rotating the cube. So I'm not sure I've explained this very well earlier, but because we're being called every, this render function is being called every frame, so 60 frames a second, each time it's called, we add a little bit of rotation to the cube. So it's slowly, well, very quickly in fact, rotating. But now we're only going to do it if a key is being pressed. So if I refresh the page, the cube isn't spinning, but as soon as I hit the spacebar, it starts spinning. Good. Okay. But it doesn't stop spinning, so what we'd like to do is handle another event, the key up event. So that's saying that a key is stopped being pressed, and we'll pass in false. So now, when I push the spacebar down, I'm holding it down. The cube's spinning. When I lift up, it stops spinning. But what we really want to do is move the cube around. So rather than having any key down boolean, we'll have a is left pressed and is right pressed. And we'll start them as false. And what we want to do to distinguish between the keys rather than have just look for any key is check the key code of the event. So the easiest way to find out key codes in JavaScript is to Google JavaScript key codes. And there's this really nice website called keycode.info. And what you can do, we're going to use the W, AS, and D keys to control our cube. So what we can do is press the A key and find out the key code for A in JavaScript is 65. So we can say if the key code equals 65, then we're handling the A key being pressed. So is left press equals is key down, either up or down, depending on which event got handled. And we can do the same for right with the D key, which is 68. And let's just change this code. So we'll check that it is left pressed boolean on the input object. And excuse me a sec. Hi, Matty Plays. How long have I been doing JavaScript? Well, I've been a developer for a programmer for nearly, well, over 10 years, I think now, that I graduated from university. So I've been doing this stuff a long time, and almost all that time I've been doing some JavaScript because it's the language of the web. Almost every developer does some JavaScript. So yeah, I've been doing about 10 years. In terms of doing games with it, it's probably been possible to do decent games for maybe about the last 5 or 6 years. And I've been sort of playing around with it since then. So we're going to move, rather than the rotation, we're going to move the cube's position, and we're going to move it on the x-axis by 0.1. And we'll move it down the x-axis. So we're going to decrement the x-axis to move left, and to move right, we'll increment it. So if I refresh the page now and press A, it moves to the left, and D, it moves to the right. Let's zoom out a little bit on our camera by moving it down the z-axis. Left, right, left, right. And let's do up and down as well. So is up pressed and is down pressed. Bit copy and paste, and then we'll use the W and S keys. So W is key code 87. So it is up pressed, and then S is key code 83. Is down pressed. And we'll move, instead of moving on the x-axis, we'll move on the y-axis. So if we're going up, we'll move up, we'll increment the y-axis, and if we're going down, we'll decrement the y-axis. We'll make the number lower. So now I should be able to move this cube all around, up, down, left, right, diagonally, everything. We've got a cube that we can move with W, A, S, and D. So that's the basics of how to set up a Three.js app and then have it respond to keyboard input, which is the basics really that you need for making any games. So I hope that's really helpful. Before I go, we'll just do a little bit of housekeeping. So it's not really, I don't really like to have all of my main game code in HTML file. In fact, I like to have no JavaScript in HTML file at all. So we'll move it into a main.js file. So we'll import js/main.js, create a new file, and we'll just remove all this code, cut it, and paste it, and call that main.js, saved in the JS folder. Use.js, yep, that's fine. Clear out this HTML a bit. And then, what else do we need to do? Okay, so also I like to have my my JavaScript code in one folder, and then the code, anyone else's code that, you know, like any libraries I'm using, in another folder. So we'll create a lib folder, and then we'll move the Three.js file into the lib folder. And then update the import. So if we refresh the page now, yeah, everything's still working. So we didn't change anything functionally, we just tidied the code up a little bit. Another thing we want to do is fix our render function a little bit. So at the moment, every frame we're moving the cube about the same amount, 0.1. And this is fine when the application is running smoothly and Chrome is calling us every frame, so 60 times a second smoothly. But if someone's machine wasn't quite as good, so the game was lagging, or if the game itself was a bit resource intensive and we weren't running at 60 frames a second, the cube wouldn't move around slowly, it would sort of jump around. So what we're going to do is, instead of moving 0.1, we're going to move an amount scaled by the amount of time since the last frame was called. So what we're going to do is keep track of a timestamp. And what happens with this request animation frame is that when it's called, it passes in a timestamp which is constantly going up, and it tells you like how much time has passed since you started animating, since the first time you called request animation frame. So what we can do to find out how long since the last frame was called since the last frame was rendered, is take the current timestamp and subtract the last timestamp. And that should give us a number in milliseconds since the last frame was called. And the last thing we need to do is just remember the last timestamp for the next frame. So let's just log that time delta. Oops. So we can just check it's working. Another small fix we need to do is we can't call render now. We need to always ask Chrome to call us. Okay, yeah, so pretty smoothly you're getting called at 60 frames a second. I can tell this because this is a number in milliseconds since the last time, since the last frame. So 1000 milliseconds in a second divided by 60, 16.666 milliseconds. So we're getting called 60 frames a second. I actually like this time delta to be a fraction of a second rather than a number of milliseconds, so I like to divide it by 1000. And then now what we can do is, now we've got a fraction of a second since the last frame, we can move the cube by a certain amount scaled by that time. So if we're moving 0.1 for every frame when we're running at 60 frames a second, and then suddenly everything slows down and we're getting called at 30 frames a second, then we really shouldn't move at 0.2 every frame, because the number of frames per second is halved, so we need to double the amount we move. So the way we do that is we'll have a variable called movement speed, and we'll say it's let's say it's about 5 times the time delta. So that'll actually give us 0.16 times 5, about 0.8 per, is that going to be too big? Let's find out. 0.8 per frame. Okay, so let's press refresh and move the cube around, and it's still moving just as it was before, but trust me, it's a lot smoother now. So if we did have something on the machine that slowed things down a bit, it would still be moving at a constant rate on the screen. One more thing to show you. So someone on the channel asked about how I serve things from local host instead of off the file system. So what that means is that at the moment we're just loading this HTML file off of the file system, and you'll find later on when you start trying to do things like load textures or use WebSockets that isn't going to work. For security reasons, Chrome won't let you do that. So the easiest way that I know to do this is from the folder where you created the index.html file. If you have Python installed, now on a Mac, Python will be installed by default. On Windows, I'm sure you can install it pretty easily by searching for Python and downloading it here. And then what you can do is run Python -m simple HTTP server. And what this will do is serve all of the assets in the current folder, any of its subfolders, over HTTP as if it was a web server rather than off the file system. I would recommend this for any sort of production app if you're actually putting it out on the web for real, but while you're developing, it's really handy. So we can see we're serving HTTP on port 8000. So instead of going to the file system, if we go localhost 8000, here's our app again. Nothing's changed, but we're serving it over the web now. So that's how you do that. If you want to change the port, if for some reason you're already using port 8000 on your machine for something, you can type a different number in, and now it'll run over port 8080. And obviously, if you wanted to simulate it being like a real website, although there's not really a good reason to do this when you're just running locally. Oh, no, I'm not allowed to do that. Never mind, you can't do that, on a Mac at least. Okay, so that is everything. I realise that most of the code we've used has been from the Three.js website and not my own, but hopefully you find it really useful. Please leave any comments and questions about it, and I'll try and answer them. And I'll also put this code up on GitHub so you can all access it, and I'll link to it in the description of the video. Thank you for watching, and see you next time.